In the diagram, AC is parallel to ED. So AC is parallel to ED. So AC is parallel to ED. So I've drawn in these little lines which represent parallel lines. These little arrows. So they show that the two lines are going in the same direction. The angle DEF is equal to 40 degrees. So DEF is 40 degrees. The angle CDE is 33 degrees. So CDE is 33 degrees. And AFE is 100 degrees. AFE is 100 degrees. Part 1. Calculate the angle BAC. So BAC, so this angle in here. And explain your reasoning. So I've drawn out the diagram again a little bit bigger. And I've added in some extra bits. So I'm going to first of all add in that ED is parallel to AC. And I've drawn in this extra line here that is also parallel to ED and AC. You can extend this line the whole way if you want to, but you don't really need to. So we have three parallel lines, ED, this line that I've drawn in going through point F, and AC. So I've labelled a few of the other angles that I'm going to use. So I've labelled this small little angle here as angle 1, this here is angle 2, this here is angle 3, this here is angle 4, angle 5, and angle 6. You can label them in whatever way you want. You don't have to label them using numbers. You can label them using Greek symbols or any sort of symbol really, or you could label them as numbers in a different direction. There's no set rule as to how you label them, so long as when you're talking about them, you're talking about the right angle. So, draw a line through F parallel to ED and AC. That's what I've done there. From the diagram, by alternate angles, angle 1 is equal to 40 degrees. So we have two parallel lines and a transversal cutting through them. So angle 1 is also equal to 40 degrees because alternate angles are equal. So angle 40 degrees is alternate to angle 1 because these are parallel lines and this is a transversal cutting through them. So these are equal. So angle 1 is also 40 degrees. As angle BFE is equal to 100 degrees, so angle BFE is 100 degrees. So angle 1 and angle 2 together is 100 degrees. Then angle 2 must be 60 degrees because 100 degrees minus 40 degrees leaves us with 60 degrees. So angle 2 must be 60 degrees. It's a really good idea to draw large diagrams and to add in all the bits of information that you gather as you go along. So I found this to be 40 degrees first, so I've drawn it in, and then I found this to be 60 degrees, so I've drawn it in as well. So by alternate angles, angle 3 is also 60 degrees. So angle 3 is alternate to angle 2, and angle 2 is 60 degrees, so angle 3 is also 60 degrees. So remember we have a parallel line and another parallel line, and we have a transversal cutting through them. So angle 2 is alternate to angle 3, and alternate angles are equal. So if angle 2 is 60 degrees, then angle 3 is also 60 degrees. So angle 2 is 60 degrees, and it's alternate to angle 3, which is also 60 degrees. Remember, alternate angles make a Z shape. So angle 40 degrees and angle 1 are alternate, so they make a backward Z shape. And angle 2 and angle 3 are also alternate, they make a forwards Z shape. So remember, alternate angles are equal. So from a straight angle, so angles on a straight line add up to 180 degrees. Angle 4 is going to be angle 180 minus 60, which is 120. So angle 4 is here, and we can see it's on a straight line with angle 3, which is 60. So 180, take away 60, will leave us with angle 4. So angle 4 is 120 degrees. So we have a straight line, and angles on a straight line add up to 180 degrees. So 180 minus 60 leaves us with 120. So angle 4 is 120 degrees. So angle 4 is actually the angle BAC. And we are asked to calculate BAC, explaining the reasoning. So if angle 4 is equal to 120 degrees, then angle BAC is equal to 120 degrees. And we've explained why. Part 2. Prove that the length of AB is greater than the length of AC, explaining your reasoning. So we want to prove that the length of AB, which is drawn here in our other diagram, is greater than the length of AC, which is drawn here in our diagram. So as AC is parallel to ED, so AC is parallel to ED, then by alternate angles, angle 5 is equal to 33 degrees. So angle 33 and angle 5 are alternate angles, and alternate angles are equal. So if we look a bit closer, we have our parallel line ED, our other parallel line AC, and then CD is a transversal that cuts between them. And now we have the angle 33 degrees being alternate to angle 5, so angle 5 must be equal to 33 degrees. So this angle is 33 degrees, and this angle is 33 degrees because they're alternate angles, and alternate angles are equal. Now consider the triangle ABC. So ABC. By the angle sum, angle 6 plus 120 plus 33 is equal to 180 degrees. So remember, we got angle 4 to be 120 degrees in part 1. So we have 120 plus 33 plus angle 6 will give us 180 degrees. So to figure out what angle 6 is, we're going to say 180 minus 120 minus 33 will leave us with angle 6. So 180 minus 33 minus 120 leaves us with 27 degrees. So angle 6 is 27 degrees. So angle 6 is 27 degrees because the angles in a triangle add up to 180 degrees. So, as angle 5 is greater than angle 6 by the longer side greater angle theorem, so angle 5 is going to be greater than angle 6, then the side AB must be greater than the side AC. So angle 5 is opposite the side AB, and angle 6 is opposite the side AC. So angle 6 is opposite the side AC. And we know that with triangles, the biggest angle is always opposite the biggest side, the smallest angle is always opposite the smallest side, and the middle angle is always opposite the middle side. So if angle 5 is greater than angle 6, then the length AB must be greater than the length AC, because the side AB is opposite angle 5, and the side AC is opposite angle 6.